Hello students, welcome back. In this session we are going to discuss some of the problems that we have got from a pre-final examination. This is set number 3 questions. So let's start with the first question. A fixed point is at a distance 60 mm from the fixed straight line. Trace the path of the curve. If eccentricity is 2/3, draw the tangent and normal at the distance of 40 mm from the directrix. So here let's split the question and get the required data from the question. Fixed point is at a distance of 60 mm means focus point from the distance of straight line, that is directrix, d dash. So d dash distance of focus point is 60 mm and eccentricity is 2/3. So this is an ellipse. Draw the tangent and normal from the 40 mm from the directrix. So let's write down the given data here. Here d dash and the focus point distance is 60 mm, is 2/3, that is ellipse, and tangent and normal should be drawn at 40 mm from d dash, right? So let's start the problem here. This is directrix, fixed straight line d dash, and this is AF 60 mm. From here I'll be taking 60 mm. This is focus point F, and here our eccentricity is 2/3, means we have to add 2 plus 3 is equal to 5 parts, means we have to divide this 60 mm into 5 parts. I'll be dividing each part 12 mm. 1, 2, 3, 4 and 5. So this is 0, 1, 2, 3 and 4 part. So here coming to the eccentricity, we have to locate the vertex point at numerator, right? 2 parts from the focus. So here 0, 1, 2, 2 parts. So here we have to locate the vertex. From here we have to draw the straight line. Take the compass, measure the distance, draw an arc which cuts the straight line. From here, from the A, we have to draw an array. Right? Then take appropriate divisions on this focus line. This is the vertex focus. So I'll be taking 1 centimeter line apart. And from here, draw the line which cuts this array up and down. Even you can take this array down also, but no need. If you repeat the same process of measuring the distance from here and keeping it the focus, we can draw on the same lines. So no need of extra lines. The array will be going so on until we finish the focus. And finish the ellipse. So let's name them 1, 2, 3, 4, 5, 6, 7, 8 and 9 and so on. Now measure this distance from this line to this line. This perpendicular is cutting this one, right? So measure this distance. Keep it F, draw an arc. This is the first point. Next, measure this distance, keep at F, cut on 1, up and down. Next, on 2, keep on F, cut on 2. Next, 3, keep on F, cut on 3. Next, coming to 4, cut 4 line, keeping on F. Next, 5, next 6, 7, 8, 9, and so on. You will be getting the points like this. So these are the points. You can get the points here also, but for the time consuming, I am not drawing all the lines, but the method is same. Lines, perpendicular lines that cuts the array, and from the array you have to measure this point and keep on F and draw arcs. You will be getting like this. So join these points, right? So mention this P0, P1, P2, P3, P4, P5 and so on. Here coming to this one, P1 dash, P2 dash, exact P1 down, P1 dash, P2 down, P2 dash, P3, P4 and so on. You can complete the arc by freehand diagram, freehand methods. Or else you can follow the French curve. You can use these type of French curves. You can choose the appropriate shape of the French curve for drawing from one point to the another point. You will be getting a neat curve. Here you can get the neat and smooth curve by using these type of French curves. You'll be having a bigger set also. You can use for the appropriate shape of your diagram. My diagram is a little bit small, so I'll be using the small French curves. If your figure is big, so you can use the bigger one. Method is same. Now we have finished with these things. Let me mention the dimensions over here. This is 60. Now it is given in the question that you have to locate the tangent and normal 40 mm from the directrix. So let's take the 40 mm distance from the directrix. So this is the 40 mm distance and draw a line which curves the curve. So at this point we have to locate the tangent and normal. This is the point on which we have to draw the tangent and normal on this curve. So you can draw above or below also it is touching. It is not mentioned that you have to draw the above or below. So you have it would be easy for taking the above one. So let's take this point M. from M you have to draw a line to the focus. From the focus, taking this line onto one scale, and you have to draw the perpendicular line to another one from F to the D dash. This is the point where it is touching the directrix. This is 90 degrees over here. Now you have to draw the lines from this point to this point. So this would become tangent, and perpendicular to the tangent you will be getting a normal. Here you can observe only the curve is dark and tangent normal is dark, and coming to the reference points are dark. Other reference line, this line, and other perpendicular difference lines or arcs or 90 degrees lines are very light and thin. So whenever you are drawing the engineering graphics or drawing, you have to show the main drawing dark and others very light. I hope everyone understand this question. A fixed point is at a distance 60 mm from the fixed straight line. Trace the path of the curve if eccentricity is 2 by 3 and draw the tangent and normal at a distance of 40 mm from the directrix. For this question, this is the answer. I hope everyone understand this one, how to draw it. Now we are discussing the set 3, question number 2. Let me read out the question and abstract the given data from this. 2 points A and B are 100 mm apart, and point C is a distal distance 65 mm from A and 50 mm from B. Draw an ellipse passing through A, B, C. So this comes an parallelogram method, because the point C is 65 and 50 mm from A and B line. So A and B points on the line. So this is an parallelogram method, but here the angle is not given, but the distance of another point. Let's consider this A and B has V1 and V2. Vertex points means ends of an ellipse, and this has minor axis end point, distance from A and B. So let's write down the given data from the question. AB is equal to 100 mm. C means AC is equal to 65 and BC is equal to 50, right? And coming to the AB, that is V1, V2, this is the major axis, and C and D, another point C and D, that would be the minor axis. So major axis and minor axis would be passing exactly center to the major axis. So let's write down, draw the major axis 100 mm and draw this one. I'm drawing very light. This is 100. This is A. This is B. And coming to C, from A, C is at 65 mm. Right, this is 65 mm. From A it is 65. From B it is 50 mm. Right, this point would be C. Right, so this is the midpoint, and you have to draw the line from here to here and measure the distance. And draw down. So this point would be D. So with this we can construct an parallelogram and be keeping the drafter parallel to this CD line, and I'll be drawing this. And I'll be keeping the drafter parallel to the AB and drawing this line, completing a parallelogram. Here in some questions the angle may be given, this angle may be given, or else these type of questions may be given. The distance from A is 65 and B is 650 in this manner, but you have to follow the same method. Now you have to divide this line into equal number of parts. This is 30. I'll be dividing this into 3 parts. 1, 2, 3. 3 parts. This I'll be dividing 3 parts. Here also 3 parts. Here also 3 parts. This is 50. So I'll be dividing this 50 into 3. 50 by 3. I'll be getting 16.6. From here 16.6 plus 16.6 would be 33.2. Another would be 49.2. 16.6, 33.2, right? These points are the divisions of the major axis and the minor axis, right? Let me mention this. This is 0, 0, 1, 2, 3, 1, 2, 3, 0, 1, 2, 3, 1, 2, 3, 0, 1, 2, 3, 1, 2, 3, right? Now we have to join these lines for the minor axis endpoints. Right, we have joined this. Now from the opposite end of the minor axis, from the respective points 1, 1, 2, 2, 3, 3, we have to follow this method. From the opposite end of minor axis to the 1 and to 1 line. Next opposite end of the minor axis to the 2, next to 2, next 3 to 3. Here also 2 to 2, 1 to 1. And these are the points. Next from here 1 to 1, 2 to 2, 3 to 3, and here also from 2 to 2, 1 to 1. These are the endpoints of the minor axis ellipse. Now you can draw a freehand stroke which joins all these points or else you can use the French curves. Now if you are satisfied with this light stroke, then you can darken this one. And mention the points P1, P2, P4 and so on. Right, this is the ellipse for this type of question. Here it is not asked that you have to draw the tangent and normal for these type of figure. So by this, if we draw like this, we will be getting 15 marks out of this question. So here also you can see that I have drawn the ellipse and dark, and I have mentioned the dark points. The rest of all is very light. I hope everyone understands this one, and we are going to discuss set 3, third question. Let me read out the question for this. A line measuring 80 mm long has one of its end 60 mm above the HP and 20 mm in front of VP. The other end is 15 mm above the HP. The front view of the line is 60 mm long. Draw the top view and get the required data from the question. So let me write down this data. This is set 3, question 3. So coming to the given data, line is given 80 mm low. So let me mention the line name as AB. So 80 mm and this true length. Now top view of the line is given front view of the line is given has 60 mm, that is A dash B dash would be 60 mm, and one of the point is above 60 mm and 20 mm in front, means let I be considering the point A is 60 mm above the HP and 20 mm in front of VP, and another point is 15 mm above the HP and in front of VP is not given. So we have to use these data and obtain the location of these points. For this, let me draw the reference line over here. Now the point is given that A 60 mm above and 20 mm in front of VP. So let's start the problem over here. The distance is 60 and 20. So I'll be fixing the one of the point A dash and A over here. So let me draw the dimension lines. So later words we may forget this. 60, this would be 20, and let's draw the locus line. This is locus line of A dash, this is locus line of A. Now another point B is given 15 mm above, right? So just I'll be taking the locus line above 15 mm. This would be locus line of B dash, because B is 15 mm above. On this line only we'll be getting the B dash. So in the question it is given that front view means A dash B dash. So this is A dash, on this we'll be getting B dash. So distance between that is 60. So let me measure the 60 and keeping on A dash, just draw an arc which cuts this one. This would be B dash, and this line is front view. This is front view 60 mm, right? Now the true length is given as 80 mm, so measure it 80 mm. And draw here. Now if one point is B dash, another point would be the reference point. Let me take as V1 dash, and A dash and V1 dash is the true length. Let me draw it light. This is true length 80 mm, right? Now down to the A dash you'll be getting A, means down to the B dash you'll be getting B. So let's draw the projector from the B dash. Means on this line only you will be getting the B, right? A dash A, B dash B. Now draw the line from B1 dash to the locus line of A. This would be B1. Now measure this distance A and B1 and draw it down, which cuts this line. Means this point would be B dash B, right? Let's join this, and this is the top view, and let me measure this. This is around 67, right? So we have obtained the top view length. So in the question also it is given that draw the top view. It is very simple, right? So we have drawn reference line, just 60 mm above, 20 mm below, and this distance is 15 mm, right? The height where the B dash is located above the HP. This is 20. I have located A dash A. Then I have drawn this locus line of B dash, and let me mention this is also B1 dash. Then have taken a 60 mm arc from here to here. This is front view. Next 80 mm from here to here. It is 80 mm. This is B1 dash reference. This is B dash. Down to that only we will be getting B. So from here draw the line, projector line. From here taken locus arc. This is locus arc of B, right? So in this way we have finished our problem. I hope everyone understand how to draw this type of line problem, projections of line. Now we are going to discuss the fourth problem. This is set 3, question number 4. Let me read out the question. The top view of a line 80 mm long line measures 55 mm, means the top view is 55 and the front view is 65. The end of a line AB is 40 mm above the HP and 30 mm in front of VP. Consider end B is nearer to the VP and far from the HP. So let me write down the given data from this question. There is a line AB 80 mm and the front view A dash B dash is 65 and AB, the top view is 55 and one of the end of the line AB is 40 mm above, means A dash is 40 mm above the HP and A is 30 mm in front of VP, and another point, that is B, is far from HP and B is near to the VP. So let's start the problem. XY, I'll be locating the A point, that is 40 mm above the HP and 30 mm below the VP. This is A dash, this is A, this is 30 mm, this is 40, right? Let's draw the locus lines. LL of A dash, LL of A, right? Now the front view is given 65 mm, so let's measure 65 mm with the compass and draw an arc on this, right? So this point would be B2 dash, right? And let's measure the top view also. that is 55. This point would be B1, right? So just draw the perpendicular from B2 dash down and B1 up. Next, measure the true length, that is 80. Keep on A, draw it. This would be B2 point and this would be P1 dash, right? Now draw the locus lines from that particular point. This would be locus line of B2 and B, and this would be the locus line of B dash and B1 dash. Means already it is drawn with the arc. This arc is 65 and this arc is 55. So this end point would become B and this end point would become B dash. Now you can see under A dash you will be lying with the A. Now see B dash and B, both are on same line. Let's show you. See here, under B dash your B is coming, right? This is a projector line. Okay. Now finish off this. This is front view 65. This is true length 80. This is top view 55. And this is true length 80, and this arc is locus arc of B dash. This is locus arc of B. With the given data we have finished the problem. Let me read out the question once more. The top view of the line, a 80 mm long line, is 55. See here the 55, and the front view measure 65. See here 65. The line of end of the line AB is 40 mm above. See here 40 mm above. This is origin 1, this is origin 2, and 30 mm in front, 30 mm in front. Consider B is near to the VP, far from HP. See here, this is nearer. Let me measure it. This is 75, and see here this length is 75 and far from HP. See here from the origin this is 95. So far from HP, near to the VP. Far from HP, near to the VP. So with this we have finished this problem. I hope everyone understand how to draw this type of problems. And now we are going to discuss the question number 5. Let me read out this question. A square lamina means ABCD square plane is 40 mm side, has a corner A in the HP and its diagonal AC is inclined at 45 degrees to the HP, while the diagonal BD is parallel to HP and inclined at 30 degrees to the VP. Draw its projections. So let's write down the given data. This is set 3. Question 5. Given data would be square plane, lamina or plane, we can consider same. Square plane ABCD. Side is 40 mm. A is in HP and diagonal AC is 45 degrees to the HP, means this is theta, right? And diagonal BD is parallel to HP and inclination with the VP is 30 degrees to VP. So let's start the problem. Let's start the problem here. I'll be taking the 45, see here, A is in HP and AC is 45 degrees inclined to the HP. So now I'll be taking the figure like this. Our plane is 40 mm of side. This is the square lamina or square plane, and this is A, this is C, this is B, and this is D. Mentioning the dimensions over here. And in the question it is given that A is lying in the VP. Let me extend this a little bit here because the problem would be coming over this position. And let me project this. So this point would be A dash, and this point, when you're looking in this direction, first B dash, then D dash, then C dash. So let me darken this. Right. Next, diagonal AC is 45 degrees inclined to the HP. This may, you can consider this as HP, this as VP. HP rotates like this. So top view comes here, front view comes here. Right. So let me keep this 45 degrees. Array. Measure this. This point A dash, this is C dash, this is B dash, D dash, means diagonal AC is 45 degrees, theta of 45 degrees to the HP. Let's darken this. Now project this down for getting the top view. And project this side. So this points, this is A, B, C and D. So our diagonal AC is inclined at 45 degrees to the HP, and we have finished this one. Next we are going for BD parallel to HP and 30 degrees inclined to the VP. Now we are making this BD diagonal 30 degrees inclined to the VP, means this is the VP, this is the HP, like this. So your plane is making 30 degrees to the VP. So let's draw an array of 30 degrees. On that array we will be drawing our reproducing the same figure over here. This is the change of position method. (30 degrees array). This is phi 30 degrees. Phi equal to 30 degrees. Now we have to reproduce the same figure over here. This would be D and this would be B, right? And this would be A, this would be the C. Let's complete the figure with this point. We have reproduced the same figure over here. Now draw the projectors above from top view to the front view. Right, and then front view to the side, right? Now this A projector is going above and A dash projector is coming this side. So A and A dash intersection, this would be A dash. And C projector is going above and C dash projector is coming here. This would be C dash. And B projector is coming here and B dash projector is coming here, B dash. Next D projector is coming here and D dash projector is coming over here. So this would be the D dash. Let's join this. Now see here, coming to the question, it is given that AC, diagonal AC is 45 degrees inclined to the HP. See here, now AC's diagonal is 45 degrees inclined to the HP. Same figure is coming over here, right? AC is 45 degrees inclined to the HP and BD is parallel to HP. See here, BD is parallel to HP and means height. If this is the HP, BD would be like this. If this is the BD, height from the HP would be same, parallel to the HP, but this is the VP, right? Inclined to the VP 30 degrees. See here, inclined to the VP 30 degrees. Inclined to the VP 30 degrees. And this one AC is inclined at 45 degrees. So by this we have finished this fifth problem. 3 problem 6. So this is a given data, rectangular plate of size 60 and 40 means length is 60, width is 40, has its shorter edge, that is 40 mm on HP, and it is inclined such that the top view of the plane appears as a square having 40 mm side. Draw its projections when the edge of the HP is resting on and inclined at 30 degrees to the VP. See here, it is already given that the top view is the square and the front view is a rectangular plate of 60-40, right? Means one of the shorter edge is on HP. So here given data, rectangular plane, plate, plane or lamina would be the same, 60 and 40, shorter edge on HP, top view is a 40 by 40 square, and draw the projections when shorter edge is 30 degrees to the VP, right? So let's start the problem. So the top view of this rectangular plane is a 40 by 40 square. So let's name the shorter edge as A, B, C, D. The shorter edge would be AB and DC, and this would be the longer edge because there's a rectangular. And one of the edge is on HP, right? So I'll be keeping the B dash and A dash on the HP, and let's measure the 60 mm length. 60 mm length, and from here mark it. This would be C dash and D dash, and this would be $60, and this would be 40, right? Now the shorter edge is inclined at 30 degrees to the VP, means this edge is inclined at 30 degrees to the VP. So let's take it 30 degrees. This is 5. And draw this over here. We have reproduced the same figure over here. This would be the A, B, C, D. Now draw the projectors from this to the front view. Okay, from B to the B dash, this would be the B dash, and from A to the A dash, this would be the A dash, and from D, you have to draw the projectors over here. From D, D dash, this would be the D dash, and from C, C dash, this would be the C dash. Now we have got points. Now join this. Right, this is the front view, this is the top view. Already it is given that the top view of this rectangular plate appears as a square. Here this is the square of 40, it is satisfied. Next, draw the projections when the edge of the resting, means this A dash and B dash, is inclined at 30 degrees to the VP. See here, this is 30 degrees to the VP. So in this position we have to draw the projection front view and top view. Top view is a square, it is already given, so we have drawn here, we have reproduced here. So for these type of questions you can go for a 3-stage problem, means previously you can draw a rectangle, then you can second stage would be this one, third stage would be this one. But already it is given as top view is the square, so I have drawn the square over here, so this would be the time saving thing. So with this question is satisfied with the given format of question. This is the solution. Now we are going to discuss question number 7. Let me read out the question here. The cone of base diameter 75, axis 80, long is resting on the HP with the base. Means this is the cone, this is resting on the HP with the base. It is cut by a section plane perpendicular to the VP and inclined at 45 degrees to the HP, means auxiliary inclined section plane. Cutting the axis at the point of 35 mm from the apex point, means from the top of the apex, means the height of the cone is 80, means from the top 80 point 35 mm below the apex point. Draw its projection: front view, sectional top view, sectional side view, and true shape of the section. Means here we have to draw the 4 views: front view, top view, side view, and the true shape of the section, right? So this is set 3, question 7. Let's start the problem. Cone diameter 75, axis 80, cutting at 35 from apex, right? By auxiliary inclined section plane 45 degrees to the HP. So let's start the problem. I'll be taking the XY over there. And the main axis here, right? And here will be coming the side view, here the top view, front view, true shape, side view. The diameter of the cone is around 75 half, 37.5. So whenever you are drawing any of the solids, you have to go for the base true shape. Here the cone base true shape is a circle. I am drawing the true shape over here. Then I'll be projecting this for the front view. Here I am not drawing this dark because I don't know which part is remained and which part would be removed, because it is a section of solids. This is top view, this is front view, and here I'll be drawing the side view also, because it is asked in the question. We have to draw all three views. If this is XY, this one would be X1, Y1, because you may get two side views, left side view and right side view for the first angle of projection, and reverse for the third angle of projection. Coming for the side view, if you are drawing like this, this would be very convenient. Let me extend this. Normally this is the projection of a cone, because we are cutting this, and these are the end generators of this cone. We have 4 end generators, 1, 2, 3, 4 generators. Here also 4 generators, but this won't be sufficient for our diagram, so I'll be taking more end generators. So I'll be dividing this into 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8 parts. So let's project that above. This is 1 dash, this is 2 dash and 8 dash, this is 3 dash and 7 dash, this is 4 dash 6 dash, and this is 5 dash over here. Coming to this one also, we have to draw that same. This point would be 7 double dash, and this one would be 8 double dash, 6 double dash, and this one would be 1 double dash, 5 double dash, and coming to this would be 2 double dash and 4 double dash, and this would be 3 double dash. And coming to the apex point, this one would be O1 and bottom would be O2. This is O2 dash, this is O1 dash, O1 double dash, O2 double dash. Let's join these also. Now coming to the section plane, don't draw these lines dark now itself. After finishing the section, then we'll go for darkening the remaining portion of the cone. Now our section plane, auxiliary inclined section plane, is 45 degrees to the HP, and it is cutting the cone exactly 35 mm below the apex point. This is the apex point, and 35 means from here our section plane is cutting the cone. So let me keep this for the 45 degrees, right? And I'll be cutting this one. Long dash dotted lines is a section plane, and you have to indicate this mark means this portion. Arrow mark means this is removed and this is remained, means this I have to draw light, means this is remained, and this is I have to draw dark, this is remained. So now I'll be darkening this. Right, now this portion is remained and this portion is remained for the bottom, so I can dark this bottom also. Because the bottom of the cone is not disturbed with the section plane. See here, the section plane is not touching the bottom, so I can draw this dark. So this portion light, this portion dark. Now you've got some intersection point with this section line to this generators. So let's name them. This is P dash, first one. Let's go in this direction. This is PQ. Next this one PQR. Next this point, yes. This point PQR, yes. T dash. Next coming to this one on this generator PQR, yes. T U V W dash, right? These are the points, and this can be considered here directly, right? Now coming to the projector, from the front view already it is a section part, we have to project that down, we have to project this side, right? So T, yes, and U, V and R, W, P, right? These are the projected points, and we can project this down also. This P dash projector line is on 1 dash and O1 dash, 1 dash and O1. So this is P. Front view P dash, top view P, right? Next Q and W. Q and W will be falling on 2 dash and O1 dash, 8 dash and O1. So this would be the Q and this would be the W, right? Next coming to R, that is directly falling onto this. So for these type of things, you have to just draw the line up to the end generators, that from that point to the this separator or this line, and from this measure this one, draw an arc, Draw an arc. This point would be R, this point would be V, right? Next, coming to U and S, that would be falling on 6 and 4. Next, coming to T, right? P, Q, R, S, T, U. So with this point, we can finish off the sectioned top view with the light stroke lines. The light stroke lines, you can represent this over here, and if you are satisfied with this one, you can draw dark. Right, this is section 1. So for section 1, we have to represent dust with the hatching lines. Thin dark lines 45 degrees, and 2 mm or 2 to 3 mm can be the gap. This is thin dark and 45 degrees line with the gap of 2 to 3 mm. For time saving, I'll be drawing like this. You can use the drafter. Now hatching is finished. Now project these points above here, right? T, that would be falling on 5 and O1. So this is 5 and this is O1, means T double dash. Next, yes would be falling on 4 and O1. This is 4 and this is O1. Yes double dash. Next, coming to R, that is falling on 7 and 3. This would be the R double dash. And coming to Q would be falling on 2 and 8. This is 2 and 8. Q double dash. Next, P would be falling on 1 and O1. This is 1 and O1. This is P double dash. Next, coming to W will be falling on 8 and O1. See here, W double dash. And V would be falling over here, V double dash, and next would be falling U. So with this point, you can finish off the section portion of the side view. With the light stroke lines, you can finish off this. If you are satisfied with this curves, just drawing them dark. This is a section 1. You can hatch it. And this is the remained portion. So this is side view, left side view. This is front view. This is top view. So this is remained. So this dark. Now we have to find out the true shape. In either of these views, you are not getting the true shape, means original shape of this section. So for this, you have to draw the auxiliary views, taking the projectors from here. So for auxiliary views, I'll be drawing the parallel line, reference line parallel to the section, our auxiliary section line. This is x dash and y dash. Now project this, draw the perpendicular lines from this one, each and every point. Poke it for next methods, next steps. Here also poke this. Now P dash P, measure from this reference line to the P. This is the reference line, this is the reference line, x, y, x dash, y dash. Keep on this reference line, draw on this. Means P dash P, and this will be the true shape of the section. Always will be mentioning the true shape with the capital letters. This is P, capital P. Next, for a Q, on the Q dash and Q, we have got this. Keep on this here, right? Next for W, keep on W, this one. So this would be Q, this would be W, right? Next, R, keep on this, go for R, keep on this, go for R. This would be capital R. Next, coming to V, keep on this, measure V. Next, keep on this, measure V. This would be V. Next, S and U. This is the line. Coming to S, this is S. And next, coming to V, this is V. Next, coming to T, keep on T, keep it. So this would be U, this would be T, and this would be S. P, Q, R, S, T, U, V, W. Right? So with this points, join this with a free hand or else use French curves. So if you are satisfied with this curve, then draw it there. This is the true shape of section, and hatch it 45 degrees, same like this. I am not using any drafter, I will be drawing freehand. So this is true shape. This is the front view, this is the top view, and this is the left side view. So here we have finished with the draw its front view, sectional top view, sectional side view, and true shape of the section, with this we have finished the 7th problem, cone base 75 diameter and axis 80, and it is cut by auxiliary inclined section plane 45 degrees to the HP and at a point 35 mm. Means from the top, it is 35 mm. This is the diameter. I'll be mentioning this over here. (75), and this would be the height of the cone, 80. Right? So with this we have finished the 7th problem. I hope everyone understand how to draw the section of cone with auxiliary inclined section plane. 8th question, this one. Here it is given that a pentagonal pyramid of side 30 and axis 70 has its axis inclined at HP at 30 degrees and edge inclined at VP by 45 degrees. So let's write down the given data from this question. So here pentagonal pyramid, side 30, axis 70. Axis is inclined at 30 degrees to the HP, means this is theta is 30 degrees and phi is 45 degrees. Phi means inclination with the HP, theta means inclination with the HP, right? So let's start the problem. Here this problem is a 3-stage problem, means in stage 1 we have to assume the pyramid is resting on HP, means standing position like this. If this is the HP, this is the cone, pyramid, and the second position we have to change it to the 30 degrees. Next position we have to change it for the 45 degrees. So here let's start the problem. This is our main reference line XY, and here I'll be drawing the top view of the pyramid first, because whenever you are drawing the solids you have to draw the top view first, because in top view we'll be getting the true shape of the base. So for that reason we have to draw the true shape of the base first. In this condition we'll be obtaining the true shape of the base in the top view. Next, front view will be the height of the solids. I'll be drawing the pyramid pentagon like this, side 30, the simple way of drawing any of the pentagon would be calculating this. Already you have 2 points A and B. You have to get the C, D, E and again A. So for this, for these type of things, you can calculate this distance, means height of the pentagon. From the midpoint of the AB, just draw the perpendicular line and measure this distance has 1.54 into S. S is 30 over here, the side, means 1.54 into 30 would become 46.2. Just take a point 46.2 over here, means this point would become D, and just measure this 30 mm over here. Draw an arc from A, draw an arc from D, draw an arc. So this point would become E, this point would become C. This is a very easy method for drawing any of the pentagon. Because in solids you have to consume the time, so for that reason this method you can obtain very easily. Now this is the pyramid. We have to locate the center point of this one. This is the center point. To this center point you have to draw the line, because those are the face edges of the pentagon. Right, now you can project this straight to the front view. This is the axis. Long dash, short dash line, that would be light. So in the initial condition, I'll be making this one to rest on the HP. So the bottom base would be falling on a reference line XY. This would be B dash, A dash. This would become C dash, E dash, and this would become D dash, and this is O2 dash. And the height of the pyramid is 70. This would become O1 dash. So let's join them. So your C and O1 would be here, C dash and O1, and behind C dash and O1 dash, your E dash and O1 dash lies, and behind the B dash and O1 dash, your A dash lies. Now next condition would be tilting the figure 30 degrees to the HP. Let's mention the height. And the side. $30. Next, I have to reproduce the same figure over here. This one would be the stage 1. This one with the stage 2, reproducing the same figure over here. 1, 2, 2 would be repeated over here. Next, you will be getting 3. Next, this 3 would be reproducing over here, and this 3 would be the reference point for the second stage of the front view. Means in this condition, this is not a true final projection. This is not a final projection. Next coming stage, we will be getting the projections. Just I am tilting the axis to the 30 degrees. An array of 30 degrees from here. Next, I'll be reproducing the same structure, this figure. This is 21 and 47. And 47. This point is D dash, this point is B dash, A dash, and this is O2 dash, and from there it is 30. From here it is 30. This would become C dash, E dash, and this axis is 70. From here it would be the 70. Let's finish off this. This is the axis line, right? I'm not concentrating on that one, O1 dash, and this is O2 dash. Now we have to project that down. and we have to project this. Now this point is A, this point is B, this point is O2, this point is E, this point is C, this point is D, and this point is O1. Now coming to the solids, just finish off the outlines, then you can go for inside thing. Right, now coming to the inside, when you're looking in this direction, you can't see this bottom D, because that is under this portion. D can't be seen, so D can be in hidden form. And looking in this direction, you can see A dash O1 dash, B dash O1 dash means A and O1 you can see, B and O1 you can see. And coming to this one, C dash and E1 dash and O1 dash can be seen. Already E and O1 is seen, C and O1 is seen. Now I'll be joining the A and O1. You can't see the D, right? So that would be in a hidden form. Hidden is a short dark dash line. Short dark dash line. From O1 to O2 you have an axis line, right? This is an axis line. Now you have to reproduce this figure over here with angle 45 degrees. Means I'll be taking this AB 45 degrees and reproducing the same figure over here. Stage 1, stage 2. In stage 1 you are producing the front view over here. In stage 2 you are reproducing the stage top view over here. Means this is the final projection of top view. For with this reference, if you draw over here, you can draw the final front view. This is the top view, this is the front view. I'll be taking the angle 45 degrees. This is 45 degrees. I'll be reproducing the same figure over here. The AB would be coming onto this. A, B. Now you can reproduce the same structure over here by help of compass. You can measure AE. You can measure B. You can measure BC. You can measure AC. You can measure D, AD. And you can measure BD. This is D. You can measure BO2 and AO2, and you can measure BO1 and AO1, right? So you have to follow the same dark and hidden lines here. axis line, this is O2, this is O1, right? So you have reproduced the same figure over here at this position. Now you have to project this for the front view. This would become B dash, A dash, D dash, D dash. Next coming to E, that would be falling here, E dash. Next would be O1 dash. Next C dash. Next O2. So already we have finished A dash, B dash, C dash, D dash, E dash, and O1 dash, O2 dash, right? So O1 dash and O2 dash are the axis line. Let's finish that. Axis line is finished. Next, coming in this direction, this is stage 3-1, right? 3. So in this direction, when you are looking this, so you can see B, O1, C, and D are clearly visible. You can't see the A point in this direction, right? This is the VP, this is the HP, right? Front view, observer is looking in this direction. So you have to follow this top view for front view. Means you can see B, C, O1 and D, but you can't see A, right? So let's finish off the outlines. So I have finished the outlines. So here you can see B, C, O1, E and D, but you can't see the A in this direction. Means A is behind this surface. So A would be coming in hidden. So you can see B, O1, C, O1, D, O1, E, O1. All are dark. See here, B, O1 dark, C, O1 dark, D, O1 dark, E, O1 dark, and A dash and O1 dash are hidden. Means at this back line, hidden lines. Okay. Next, coming to AC, AE, that is hidden, AB hidden. So in this way we have to draw the projections of a pentagonal pyramid, side 30, axis 70, axis inclined at HP to the 30 degrees and edge is inclined at 45 degrees to the VP. So this is the edge that is inclined at 45 degrees to the VP, and this axis is 30 degrees inclined to the HP. With this we have finished this projections of a pentagonal pyramid. Question 9. So given data here, hexagonal pyramid of base side 30, axis 120, resting on with base on HP, and the edge of the base is parallel to the VP. Horizontal section plane passing through the point on the axis at the distance of 60 mm from the base. Means from the bottom it is cutting 60 mm above the base. Draw the isometric projections of frustum of a pyramid. Means we have to draw the projection of a remained pyramid when you sectioned horizontally, at 60 mm from the base. So for this we have to draw first the orthographic projections, then we have to go for the isometric projection of these type of frustrums figures. So here given is hexagonal pyramid, side 30, axis 120. Horizontal section plane is cutting this at 60 mm from base, right? So first we have to draw the orthographic projections of this one, and then we have to move for the isometric projections of that. So this is our reference line. This long is not required. So first I'll be drawing the top view of the pyramid. For drawing an hexagon, it would be easy for drawing in a circle method. Just draw the circle. Next, from these end points, just draw arcs. Means this is 1 point, 2, 3, 4, 5, 6 points. Let's join them. So in the question it is given that the edges of the pyramid are parallel to the VP. See here, edge of the base is parallel to the VP. See here, this edge is parallel to the VP, this edge is parallel to the VP. Now because this is a pyramid, we have to join these corners also, but I'm joining very light because this is a frustrum and it is going to be sectioned. So I don't know which part of this pyramid is going to be sectioned apart. So I'll be drawing very light here. Now I'll be drawing the projectors. Because our base is resting on the HP, so I'll be drawing the projectors only up to here, this position. And this would be the axis line. And from the base it is 120 of the height. So from each and every corners or the points I have to join to this one. I am drawing light because I don't know which part of this pyramid is going to be sectioned, so I'll be drawing very light lines. So with this we have finished the projections of this one. Next we have to section this. So from the base, let me mention the dimensions over here. This is 120. The side of this pyramid is 30. Right, at the point of 60 mm, the horizontal section plane is cutting the pyramid. So this is 60. So this is a section plane. this arrow marks indicates that this portion is removed and this portion is remained. So this portion would be light and this portion would be dark. So now I can darken this line. I have to project this top portion also here. Now I can darken this edges. Right, this is the remained figure. We have to draw this in a isometric form, isometric projection. For isometric projection, we have to keep this in a box manner. So let's keep this in a box. Let's take off this clip. Now I have kept this figure in a box. This is 0. Means in this direction we are viewing this. For isometric projections, you have to take the angle 120 degrees like this, right? In this direction, the front view. This is the right side view that falls on left. This is top view. So the angle would be 120 degrees, 120 degrees, and 120 degrees, right? So for keeping this 120 degrees, this would be 30 degrees. I'm taking one point over here. This would be 30 degrees line. And coming to orthographic projection, you can see in one view only 2 dimensions, but in isometric you can see in one figure or one drawing you can see all the 3 dimensions at the same time. So coming to this one, this is the front view, this is the top view, right? So in front view you can see the length and you can see the height. In top view you can see the length and you can see the width, right? This is width, this is length and this is height. So here we have 3, length, height and width. So we can mention all these height on height axis, width on width axis, length on length axis. So these axes, these main axes, length, height, width are called isometric axis. And whatever the line we are drawing parallel to these lines or these axes are called isometric lines. These are isometric axis and line parallel to the isometric axis would be the isometric line. So this would be the length and this would be the width because I have mentioned the 0 over here. So let's take the 0 over here. This would be the length and this would be the height. Means this would be the length, this would be the width, right? Width, length. And coming to another one, this would be the height. Length, width, height. So this is the front view. This arrow mark indicates the front view. Now keeping onto this, we can draw this box easily onto this isometric projection. Means drawing the rectangular plane or rectangular lamina or plate onto the isometric would be very easy. So for this, simply just measure this O and this corner point, because this is on width, I have to place on width. Next, from this to this point, because this is length, I have to place on length. Next, similarly, these two lines have been finished. This one here, this one here. So I can draw this easily, right? Same. This is same. Now I am measuring this. I am keeping here, drawing this. So this is a box. Let's draw it very light. Means simply you have drawn box here. Means you have a structure of a hexagon in this box. Means you are reproducing the same box over here in isometric. So you can reproduce this hexagon also in this box. So this would become very easy when you are going from orthographic to isometric projections. Now measure these points from O to this point, and from this to this, and from here to this one, and from here to this point, and from here to this point. Means you got all these points. For easy identification, you can give the name for this also: A, B, C, D, E, F, 1, 2, 3, 4, 5, 6. So now I got these points. Means this is a true shape and this is orthographic projection. So whenever you are drawing any true shape, you have to mention that in the capital letters, and in orthographic you have to mention in the small letters. So this one is B, C, D, E, F and A, these points. So this is the bottom base of this hexagon. So I can't draw this dark because I don't know which structure would be back and which structure would be front. So just I'll be drawing very light lines. Here you can see I have reproduced the base, bottom of the pyramid, or remained frustum pyramid over here. Now I have to locate the center points also, O2 and O1, right? I have to locate the center point. It is on exact AD center. You can't take center like this directly. You can take only on these box lines only, right? So this is AD. AD is 6. So exact half. This would become O2, capital O2, right? Now from capital O2, the height, this is O2 dash, this is O1 dash. From here to here, the height is 60. So from here to here, I can take 60. This is the axis, right? Next, parallel to that, I can take 1 and 4. Sorry, measure this 1 and 4. This would be 30. Keeping parallel to this one. Means you got 1 and 4, right? Let's mention over here B dash, F dash, and C dash, E dash, D dash, and this one would be 1, 2, 6, and this one would be 3 and 5, and this one would be the 4. So we have mentioned that. So you got 1 and 4 over here, 1 and 4 over here, and with the 1 and 4 we have to create the box, right? So I'll be making the box out of top surface, right? This one. I'll be making the box here, right? So I'll be drawing the parallel lines. This line, right? So from here I can measure this one. I have measured this small. I'll be keeping here arc, 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 and arc. So I'll be drawing the parallel lines. So I have drawn this. This is the length line. This is width line. These are width axis. This is line axis. This is height axis. So lines parallel to the length, width, and height axis would be the isometric lines. So similarly, how we have created at the bottom, we can create it here also. We got all the points. So this one is the 4, and this one is 5, 6, this one is 1, and this one is 2, this one is 3. So top, when you're looking from the top, you can see this structure fully visible. Means I can draw this 1, 2, 3, 4, 5, 6 has a full visible structure. Next, looking in this direction, I can see this 2 and B fully visible, right? 2 and B fully visible in this direction, right? In this direction, I can see 2 and B fully visible, but I can't see the 1 and A fully visible. Next, in this direction, I can see C, D, and E also, but I can't see A and F. So for this purpose, I'll be drawing the outlines first, then I'll go for inlines. E, this is outline. So in this direction I can see 3 and C, I can see 4 and 5, but I can't see this A, F and A1, 6 F, so they are hidden. Next I can't see B and A, so they are also hidden. I can't see A and F, they are also hidden. I can't see E and F, so they are also hidden. I can't see 6 and F, so they are also hidden. So in this manner you have to construct first orthographic, then you have to go for isometric. For these type of isometric figures, no need of mentioning the dimensions here. But because already we have mentioned the dimensions in the orthographic, 30 side, height is 120 and frustum height is 60. So this height would be 60, the side would be 30, and because this is a frustum, we don't have any top this portion. So this portion is removed. So this is the remained portion of this structure in isometric projections, right? This is width, this is length, and this is height. So if you want to draw the orthographic projections of this isometric object, this is the solution. If you want to draw the isometric, this is the solution and this is the question. Okay. These are descriptional questions, means you will be given with the question, then you have to draw the orthographic projection and then isometric projections. Okay. Directly you can't go for isometric projection because you don't have any dimensions given in orthographic projections, means compulsory you have to draw the orthographic, then you have to go for isometric. For other types of questions, let me show you. Okay, for these type of questions, this is orthographic projection, and from this orthographic projection you can directly produce isometric, means this is orthographic projection question and this is answer. Okay, for these type of questions, this is question and the answer would be this one, orthographic projections. Okay, these are not descriptional questions, these are directly given questions. Okay, these are descriptional questions. And this is a descriptional question. This is a direct given question that you have to draw the orthographic projection of this isometric figure, right? Now we are going to discuss 10th problem. Draw the views, top view, side view, and the front view, right? So for this problem, I'll be considering this arrow mark indication has a front view, means here I can see the length and height and length. So coming to side view, because I'm looking from left side, that will be falling on right side. So left side will fall on right side for the first angle of projection. For if you are going for third angle of projection, the left side of the figure would be falling on left side, the right side of the figure would be falling on right side, and the front view would be coming down and top view would be going up. So I'm following the first angle of projection for this type of problem. So the front view would be coming above the xy and top view below xy, and your left side view would be falling on right side of the drawing sheet or reference line. So let's start the problem. Before going to problem, just calculate the size or dimensions of the figure, so you can fit that in particular drawing sheet. Without calculating that, don't go directly into the drawing. That won't fit the drawing sheet, or it will come onto another figure, or else it won't cover all the surface or all the area of your drawing sheet. So for that, before going to drawing, just calculate the overall dimensions or a clear view of that one. So in this direction, this is the arrow mark, this is the observer, front view observer. Here I can see the length and height. So for coming to the length, I'll be taking this one total 70, exact at the half point, and there would be 70. So total length would be 140. And coming to the width, this is 30, this is 40, and this one would be the 10. So 30, 40, 10, that would be 80. So coming for the height, from here to here 45, from 45 to 25, 25 plus R 35 means 45, 25 and 35. 45, 25 and 35 would be 105. So I have to create for orthographic projection for these dimensions. So I'll be creating this structure, height 105, width 80 and length is 140. So I'll be placing the front view, side view and top view. So here front view, top view, side view. Because our height is 105, I'll be taking the reference line little bit down and width about 80. So I have to calculate the 80 and 105 over here. $80, 5 mm gap, reference line. Then 5 mm from here would be coming 105 here. Oh my god. Oh, the figure would be coming here. So I'll erase this one. So my drawing sheet, the A4 size paper would become small for these type of huge objects. But I can't do anything. I have to adjust in this only. The length of this one is 140. So I'll be starting the figure from here and I'll go up to here. Okay, I'll start from here. I'll have to go from here and 5 mm gap and 5 mm gap. Okay, this is side view, this is top view, this is front view. Okay, the figure would be starting from here. Right. So I have planned here front, top, side. Now coming to the front view, how many surfaces I can see? I can see this surface, I can see this surface, I can see this whole surface. Means 1, 2, 3. I can see totally 3. Oh, okay. This is divided over here. Means 1, 2, 3, 4, 5 surfaces I can see over here, and some of the hidden parts and holes. Right. So I'll be drawing from this point to this point and this point. Right. The length of this one is totally 140. So I'll be taking the total 140. Right. Next, the height from this point to this point is around 56. Next, I'll be locating this center point, this one, that is 70 from this point to this point is 70, and height is 45 plus 25. That would be 70. Exact 70. And here also 45 plus 20 will become 70. So I have located this one. I'll be just drawing the axis of the circle. Okay. Now I'll be taking the compass and I'll measure 35 from here. and this radius 35. Then I'll go for this circle. Diameter 40 means the radius would be the 20. Right. Next, I have small radius over here, this portion, that is 15. I'll be measuring 15 radius. Just I'll draw a light line. From here I have to locate the center point 15. And this one 15 means from here I have to draw that. Okay, here also the same thing, I have to repeat it. Right, the total this surface has been finished off. Next I have to create this holes and this one. That hole is 16 from this end and from here 28. From here it is 16. From here it is 28. So the diameter of the hole is 12, means I have to create a circle of 6 radius. So for creating a small circle with this compass would be very difficult. So for this I'll be using this pro circle. It's already having some of the circles in holes in this. So I have to select the diameter 12, right? This is the diameter 12. So all things are radius. This one is a 6 radius, right? This circle I have to keep it. So already I have created this axis line. So this would become easy for locating this circle. This line would become the reference point. Right? Okay. We have created the holes also. This hole, this and this, and next we have to create this 2 and 3. That is around the height of 45 from here, and the width is around 15. right? Next, there is a hidden of these two holes. That would be around the diameter of this hole is 10 mm, means from here 5 and from here 5. And the axis would be 5 mm. That would be prolonged for side view also. I'm just dragging this axis for the side view. This one also, and this one. Okay. Just for axis purpose. So next, we have finished with the front view. Here you can see 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and holes, right? So with this, we have finished the front view. Now we are going for the top view. Just I'll extend all the corners. Now for the first width is 30, then I have to create a step over here, then I have to create the 40 step again. This is 30. Next, there is a step of 16 plus 19, that will become up to here. There is a total step of this one. Next, I have to create this one. This is 40 plus 10, that will become 50. Right, in top also I can see this hidden portion of these holes and hidden portion of this holes and this holes. So I'll be extending the axis of this one. The hidden portion of this hole. And here, that is around 15. Coming for also orthographic and isometric, it is better to use the drafter fully. All the features of the drafter, meaning the angles and the parallel line, perpendicular lines from one front view to the top view to the side view, and side view to the front view. So don't use any of the other instruments for orthographic projections or isometric projections. For other types of drawings, you can use other instruments, scales and French curve, but for orthographic and isometric, please use drafter. And please set the drafter for exact tightness for the bench. This is the hiddenness of this internal hole. This hole. Okay, with this we have finished the top view, total surface 2, 3, total surface 2, 3. Rest of others are hidden. Okay, now we are going for side view. From each and every corner I am drawing a 45 degrees line. This is XY. Again I am drawing the projected lines from height. I'm sorry for this logo, I can't help it here because I don't have a bigger sheet. Okay, when you're looking in this direction, you can see this surface, and this surface, and hidden portion of this holes. And this is through full hole, right? That is about 10 diameter, and this curve is around 20. So inside I can see the full view. I'm sorry, I have drawn this 5 mm apart. Even a small minor dimension changes will result a bigger change in a final solution. So keep that in mind, and for stepwise follow this one. This axis. This is not there here. Okay, this one. Okay, up to here we have it. Okay. Now for drawing this one, I am using this pro circle. For the diameter 10, I'll be using the radius circle, this one, and for the diameter 20, I'll be using this one. From the height over here, I have to draw the tangent. At 45 height. Next thing is hidden lines. That's all. We have finished this figure over here, and we have to keep the dimensions also, these types of dimensions over here. But I don't have any place below or above this one. I have only the dimensions here. So please mention the dimensions about this figure, and please plan this one. This is x and y, and this is x1, y1 were the side view. This is left side view falling on right. This is front view, and this is top view. Mention the dimensions, length over here, width over here, and height over here. I hope everyone understand how to draw this type of given figures onto the orthographic predictions. Thanks for watching, and do subscribe it channel and follow it regularly for upcomings in engineering, drawing or graphics. Thank you.